Hey everybody, today we're going to talk a little bit about tangents. We're not going to do everything with tangents, but we're going to get started. So let's go through the basics of what a tangent actually is. So the definition of a tangent is a line in the plane of a circle that intersects a circle at exactly one point. And if you'll remember, if two figures or objects are in the same plane, we call that coplanar. Okay, so the line and the circle have to be coplanar, and the circle is intersected by the line or line segment at a single solitary point, as shown here. Okay, so in this case we have circle A, right? The tangent in this case would be VT, and the point by which they intersect is R, which is actually called the point of tangency. Now you'll also notice that we have a right angle here, and that's really the key piece of information I want you to get out of this video, is that the radius of a circle, because AR is obviously the radius of a circle will always be perpendicular to a tangent at the point of tangency, and that's going to be significant. And that's going to allow us to solve for some things using tangents. Okay, I believe I wrote that here. Yeah, I did. So if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. The point of tangency is just a fancy way of saying, hey, that's the point where this line or line segment touches the circle. Okay. All right. And here's basically an example specific to what we drew here. So if VT is a tangent, then AR, which is the radius, is perpendicular to VT. And one little thing to note, which I think is kind of cool, is that we're using notation that we learned all the way back in September. This is notation we learned in Unit 1. It's kind of neat. Anyway, so that's the key thing here. So if you have a tangent, it's going to be perpendicular to the radius of that circle that meets the tangent at the point of tangency. Okay. So here's an example here too as well. I'll show you this one. Yeah, there we go. Let's move this. So here we have an example. We have XZ is a tangent to circle Y. So here's XZ. Here's circle Y. Remember, we name a circle by its center point. Z is the point of tangency. Okay. Solve for XY. You'll notice I drew a right angle symbol here. And we're looking for XY. We're looking for this distance. Well, that's interesting because look what we have here. We have a triangle, and we have a specific kind of triangle. We have a right triangle. And you'll notice we have two of the three sides. We have the length of the radius. We have the length of this tangent, which happens to be a line segment. We're looking for this third side. Well, we can use Pythagorean theorem. Okay, we can definitely use Pythagorean theorem. And this is the hypotenuse. We know that because it's opposite the right angle. So we go ahead and plug these numbers in. So 4 squared plus 10 squared equals c squared. 16 plus 100 is c squared. And that's going to come out to be radical 116, or 2 radical 29 if you simplify it. And that would be the distance from x to y. Okay, let's do one more example. So here, right, we have a circle here, circle A. BC is tangent to circle A at point C. So C is the point of tangency. Find AC, which in this case is the radius. Okay. So again, we have two of the three sides, but this time we have the hypotenuse. We're just missing one of the legs, and we're going to solve for the leg. So a squared plus b squared equals c squared. We plug our values in. A squared is the unknown. B squared is 14. Or sorry, b squared is 14 squared, and c squared is 17 squared. We get 196, 289, subtract 196. We get a squared equals 93, radical both sides. AC is equal to the square root of 93. Okay, and that cannot be simplified. So at the end of the day, these are really just fancy versions of Pythagorean theorem. But the only reason we can do that is because we know the radius and the tangent are perpendicular to one another at the point of tangency, and that allows us to create and use right triangles. So hopefully that is helpful. Let me know if that's super confusing or if it helped, and we'll continue tangents tomorrow. All right, thanks guys.